Graders, we're going to do example 2 today out of section 4.2. You should have already looked at example 1, and if you would please do this for me, if you have not reviewed example 3, please do that first before you watch example 2. I want to strengthen your ability to use the cover-up method before I have you do example 2. So if you have not done example 3 yet, stop this video and go to example 3 and come back to this one. Thank you for doing that for me. Okay, example 2, in my estimation, is the hardest of the 3 in this section. And so we've already found the x and y intercepts. That was example 1. And then we went to example 3 and did the x and y intercepts. We found those and graphed lines from them. Now we're going to come back. We're going to do all of that. We're going to find the x and y intercepts, and the most difficult in my estimation, we're going to interpret their meanings in real world situations. And interpretation is difficult, so I'm going to go nice and slow for you. If you need to rewind me, please rewind me. All right, let's flip to the next page where example 2 is. They give us a travel application. Now let me read it to you. The Sandia Peak Tramway in Albuquerque, New Mexico travels at a distance of about 4,500 meters to the top of Sandia Peak. Its speed is 300 meters per minute. The function f of x equals 4,500 minus 3x gives the tram's distance in meters from the top of the peak after x minutes. Graph this function and find the intercepts. What does each intercept represent? Now, I'm going to do this a little bit differently than your book. So if your book is open and you're looking and taking notes from your book, you may want to go ahead and close your book at this time, because I am not going to follow suit with the book. I'm going to do this a little bit differently because I think this situation demands it. Your book has you find different points and graph several points. In a problem like this, where the numbers are so big, look at the equation. F of x equals 4,500 minus 3x, or 300x, excuse me. Those are rather large numbers. And when I see a problem like this, I am thinking to myself, hey, let's graph the intercepts. That's why I had you review example 1, review example 3 first, so that I can show you in this example how to rearrange the equation and then use the intercepts to graph our line, okay? So let's do that. I'm going to rename f of x, and of course you know I'm going to ask you this question. F of x is just code for what? Okay, if you are thinking or said out loud y, you are absolutely correct. You remember. So I'm just going to rename it so it's not as confusing. And then I'm going to turn this equation that's not in standard form, I'm going to turn it into standard form. Now remember, standard form is ax plus by equals c, and we want x and y on the same side. Well, right now they're not. So I'm going to move the x term, the 300x, I'm going to add 300x to each side. So they're going to cancel here on the right. That's what I was hoping to do. And then I'll end up with the equation 300x plus y equals 4,500. Now we're going to use the cover-up method. We're going to find the intercepts using the cover-up method. And so let's find the x-intercept first. So I'm going to rewrite it. So we got 300x plus y equals 4,500. And I'm going to cover up the y because I'm looking for the x. So let's divide each side by 300. And it looks like x is going to end up equaling 15. Awesome. All right, so that's our x-intercept. Now we need to go back and do it again, but this time we want to find the y-intercept. So what that's going to entail is we're going to do the cover-up method. We're going to cover up the x so we can find the y. Well, you know what? Y doesn't have a coefficient, so there's nothing to solve. It's y is 4,500. So now we know our two values. Now, if you don't have enough room on your graph paper and your notes to graph this particular function, then stop me for a second, go grab some graph paper, and let's do it on a separate sheet of graph paper. Okay, give me a little time, and I need to erase just for a second. I need room, so I'm going to erase. You don't erase, and you leave your stuff right there. Just get an extra piece of graph paper. And remember, we found the x-intercepts. X is 15, y is 4,500. Now we need to do a graph. And it's just going to be the first quadrant anyway, so let's just graph this. I'm not going to go all the way to the bottom. I need a little bit of room to write. I need to label my axes. I told you guys that's a very important thing when you're using a situation. Now, let's label our axes. I know clearly that x is time. So we want to label this axis time in minutes, okay? Because our tram is traveling up a mountain. So we're at the bottom of the mountain and we're going up a mountain to the peak of Sandia Peak. That's what we're looking to do. Now the y-axis, we're going to call this distance from the peak. Remember what I just said, we are at the bottom of this mountain. We want to travel up the mountain and get to the peak. We want to reach the peak. Okay, and this is of course in meters. Now we're going to have to talk about the increments. I don't have enough blocks to go by ones, and so what I'm going to need to do is choose an increment for each axis is what I'm going to have to do. So let's start with the y-axis. Your book actually graphed it not too shabby. They went by 500s. You could go by 500s or by thousands, whatever works for you. I recommend let's go by 500. So this first line that I drew right here, that'll be 500. The next one, 1,000. So there's 1,500, and here's 2,000. Here's 2,500. Here's 3,000. Here's 3,500. Here's 4,000, and then here's our 4,500. I need 4,500 because that's my y-intercept. So I'm going to mark that. That's my y-intercept. Now for time, it's really up to you. You can decide whatever increments you choose. How about let's go by threes? I definitely don't want to go by ones. That means I'm going to have 15 blocks. I don't think I have 15 blocks. So I'm going to go by threes. So we'll call that one 3. There's 6, 9, 12. There's 15. There's 18, and so on, as you can see. Okay, so 15 is important because that's my x-intercept. We just calculated that. So there's my x-intercept, and then we can connect the 2 points together, and there they are. That's our line, that's our graph that represents this situation, this function, f of x equals 4,500 minus 300x. Remember, we're at the bottom of the mountain. We're at the bottom. We're not at the top. We're at the bottom of the mountain. We want to travel up. So a lot of students will look at this graph and they'll think, oh, look, I'm going down the mountain. There I am. And actually, no, the graph doesn't show the direction the tram is going. So you're looking at it wrong if you think it's us coming down the mountain. That is not what is happening here. We are at the bottom of the mountain trying to go up. And so this is how far away from the peak we are. And that's going to help us in our interpretation of the x-intercept and the y-intercept. Okay, let's start with the y-intercept. That might be easier, I don't know. Let's just take a look. Our y-intercept is 4,500. So if we look at the name, the actual name of that point, which is 0, 4,500, both of these numbers, the 0 and the 4,500, have meaning. Now, what you have to do is you've got to look at the axes, the name of the axes, okay? So remember, the first number is our x, the movement on our x-axis, and the second number is the number on our y-axis, okay? So our x-axis means time. So what this means is at 0 minutes, so we just got on the tram and the tram actually hasn't started moving yet. At 0 minutes, we are 4,500 meters from the peak. In other words, we're at the bottom of the mountain. The peak is 4,500 meters up, and we're 4,500 meters away from it. That means we're at the bottom of the mountain. And I'll put that in parentheses. We are at the bottom of the mountain. And we haven't started moving up just yet. Okay? So I'm hoping this makes sense because the graph is misleading. The graph looks like we're at the top heading down. That's what the graph looks like, and that's not what we're doing. We're at the bottom heading up. And so we're the furthest away from the peak. We're at the very, very bottom. We haven't actually started traveling yet. So at 0 minutes, we are 4,500 meters from the peak, which means we're at the bottom of the mountain. Okay, let's go to our x-intercept. Now our x-intercept we said was 15. And of course the way that we write that point is 15, 0. All x-intercepts are some number for x, in this case 15, and y is always 0. Okay, both of those numbers have meaning. Both of those numbers have meaning. Okay, so for the x, what this is saying is after 15 minutes, because the x-axis is time in minutes, after 15 minutes, we are 0 meters from the peak. Okay, so what does that mean exactly? It took us 15 minutes to get to the top of the mountain. That's what it's saying. It took us 15 minutes to get up to the top, which is 4,500 meters. So we traveled 4,500 meters in 15 minutes. So that's why we're 0 meters from the peak. That means we're at the peak. We're not any distance from it anymore. We're at the peak. Okay, so let's stop right there. We did a couple of things that I want to refresh your memory on. Remember, we took the function right here. We took that function and we rearranged it in standard form. We found the x and y intercepts, and then we graphed it here on your graph. Now, the hardest thing is the interpretation. I think, in my opinion, my humble opinion, that's the hardest thing to do for algebra students. So if you will just figure out what the names of the points are, just like we did right here, and then look and see what the axes mean, I think you can interpret it. You're going to need practice. So if this feels weird and you feel like you can't do it, you're just going to need practice, okay? The more you do it, I think the easier it's going to get, okay? So let's flip back to the next to last page where it talks about the school store. And why don't you try this one on your own and see what you can do with it. Good luck, and if you have questions, bring them to me tomorrow.